Unit 2, Lesson 2, Perpendicular Bisectors, also known as the right bisector. So let's summarize the concepts we have learned so far. So in the last lesson, we learned how to calculate the distance between 2 points. In other words, find the length of a line segment. And we used this formula that said the distance, d, equals the square root of x2 minus x1 in brackets squared plus y2 minus y1 in brackets squared. Square root goes over all of that. So if I were to find the distance of this line here, you'd take these two coordinate points, you'd label them x1 and y1, and the other one would be x2 and y2, and you'd apply the formula. So the distance between those 2 points would be the square root of 6 minus negative 2, and that's squared, plus the difference in the y values, 3 minus 1, in brackets squared. And so that would be 6 minus negative 2 is 6 plus 2, which is 8. 8 squared is 64. And 3 minus 1 is 2, and 2 squared is 4. So 64 plus 4. And that would result in the square root of 68. Then we also learned the midpoint of a line segment. So the midpoint of a line segment would be a point that's halfway between both points, and we had a formula for that as well. It's just the average of the x values and the y values as an ordered pair. And so here's this formula that we can use to find the midpoint. And if I was to find the midpoint of between these 2 points, again, you would just use your x1 and y1 values and y1 and x2 and xy2 values as well. So here, substituting those values in the formula, both x values I'll add together, so negative 2 plus 6 divided by 2, and find the average of the y values, so 1 plus 3 divided by 2. And that would result in the coordinate 2, 2. Now here's the new one. So the new one is the perpendicular bisector, the definition of which is as follows. Perpendicular bisector is a line that intersects a line segment at its midpoint at an angle of 90 degrees. Okay, so I'm going to demonstrate what this looks like and how to find the perpendicular bisector of these 2 points. And I'm going to just label the points themselves. So I'll label this one here on the left as point A, and this one here as point B. Okay, and I'm going to write a few notes about how to find the perpendicular bisector. So first we need to find the slope. Okay, and so the perpendicular bisector is just going to be a line that's perpendicular. So it would be kind of imagine a line going through the midpoint. So the midpoint we found is right here at 2 and 2, and so it's a line that's 90 degrees to this line AB. So we need to find the slope of that line. So the slope of the perpendicular bisector is the negative reciprocal of the slope of the line segment. Of the slope of the line segment. Now, I will also write the formula. So if I were to say the slope of the perpendicular bisector or any perpendicular line, I usually indicate that with the m and the subscript of upside down t. That's my perpendicular slope. And I'm going to say that's the negative reciprocal of the line segment. So it's a negative of 1 over the slope from A to B. Okay, so what is the slope from A to B? Well, if I use the slope formula, the slope from A to B is equal to y2 minus y1 over x2 minus x1. And I said if I substituted some values here, I would say, okay, so 3 minus 1 is the difference of the y values, divided by 6 minus negative 2, which is the difference of the x values. And that gives me a slope of 3 minus 1 is 2, and 6 minus negative 2 is 8. So 2 over 8, or in lowest terms, would be 1 over 4. Now what you do to find the perpendicular slope is that you flip the 1 over 4 into a 4 over 1, and you change the sign. So if it's positive, it now becomes negative. If it was negative, it then becomes positive. So you change the sign. That's what it means to take the negative reciprocal. Okay, and negative 4 over 1 can be simplified to just it being negative 4. Okay, so the next thing you do is you substitute the midpoint into the equation of the line to find the y-intercept. Okay, so wondering what does that mean? So if I take the equation of the line, so y equals, we know the perpendicular slope is negative 4, so negative 4x plus b. We don't know what the y-intercept is. So this is the equation of the line of the perpendicular bisector. Okay, this is not the equation of the line for AB. It's going to be the one that's perpendicular. So I know the slope is negative 4. I need to find b. So we need to know a point that is on this line, and we know the point, one of the points will be this midpoint right here, 2 and 2. So if I substitute that coordinate, I can solve for the y-intercept. So here we go. So now b is the only thing we need to solve for. So 2 equals negative 4 times 2 plus b. That's going to be 2 equals negative 4 times 2 is negative 8 plus b. If I add 8 to both sides, I would have 2 plus 8 equals b. Therefore, b equals 10. And now I have the equation of the line y equals negative 4x plus 10. Okay. Now 10 doesn't fit on the graph, but I can use the slope negative 4. I can plot some points here. The next point would be down here. And I can draw 1.123. Well, I couldn't quite draw one up there, but I have enough now to draw my perpendicular bisector. Here we go. And there it is. Okay, so this is a line that crosses the midpoint between A and B in this line segment, and it is also at 90 degrees. And that's how you find the equation of the perpendicular bisector. And that ends this video. Oh, rather, sorry, whoops. Okay, one more example. Okay. Let's do one example here. So two schools are located at the points P and Q. So let's plot P and Q. So P is at negative 1 and 4. There you go. And Q is at 7 and negative 2. So 7 and negative 2 down here. Okay, I'll label them P and Q. So here's P and here's Q. The school board is planning a new sports complex to be used by both schools. The board wants to find a location equidistant from the two schools. Use an equation to represent the possible locations for the sports complex. So I'm going to connect my points P and Q. Okay, and the word equidistance means that you want to find a point that's equal in distance from either school from point school P or Q. And I should have just let me see if I can draw that line a little bit better. You want to make sure it's a proper line segment, and it's hard to get things accurate. So the strategy we're going to use is we're going to find the midpoint of P and Q. Can I get this right? Now you can just draw a line. Let's see. There you go. Doesn't quite work well either. Okay, let me try drawing it again with the ruler. There you go, much better. Okay, so I need to find the midpoint of P and Q, and I'm going to find the perpendicular bisector. Okay, so let's do that. So here I'm going to find the midpoint. So M of P and Q, I use capital M for the midpoint, and I subtract the two y values and the two x values, find the average of both. So I have 7 plus negative 1 divided by 2, and the y values 4 plus negative 2 over 2, and so the midpoint is going to be 3 on the x variable, and 4 plus negative 2 over 2 would be positive 1. So there's my midpoint at 3 and 1, and I can plot that right here on my graph as well. So here's my midpoint, 3 and 1. Okay, now I need the slope. Okay, now first of all, the midpoint itself is equidistant. Okay, so that could be a possible location for the sports complex. But if I drew a perpendicular bisector, every point on that perpendicular bisector would also be equidistant to either P or Q. So I need to have the equation of the perpendicular bisector, and that's the equation that represent a possible location for the sports complex. So if I find the slope of P and Q, I can use that to help me find the slope of the perpendicular bisector. And so the slope of between P and Q is this the subtraction of the difference between the two y values over the two x values, the difference. So now if I plug in the values, so y2 minus y1, so negative 2 minus 4 over 7 minus negative 1, which is negative 6 over 8, or we could say negative 3 over 4. Now the reciprocal, so the reciprocal slope, or the perpendicular slope I should say, is the negative reciprocal. So if I took negative 3 over 4 and I flipped it, I would say 4 over 3, and the negative sign becomes a positive sign. So this is the slope of the perpendicular bisector. So I'm going to write down the equation of the perpendicular bisector. So y equals 4 over 3x plus b. I need to know b. So to find b, I'm going to substitute the point that I know that's on the perpendicular bisector. It's going to be the midpoint, because that's the only point that's going to be on that perpendicular bisector. And that midpoint is 3 and 1. So here y is 1, and let's write it up here in a different line. So y equals 1 equals 4 over 3 times x, which is 3, plus b. Now if I solve for b, I can do some simplifications here. So 3 cancels with 3. I have 1 equals 4 plus b, and if I subtract 4 from both sides, I have 1 minus 4 equals b. Therefore, negative 3 equals b, and that's my y-intercept. So the equation of the line then is y equals 4 over 3 x minus 3. And I can plot this on my grid. Here's minus 3, it's my y-intercept. Take out my ruler again, and I'm going to draw the perpendicular bisector. Okay, and there we go. Show it's a 90-degree angle, and I can say that any point on this perpendicular bisector, this line right here, would be equidistant to either P or Q. So even if I took the y-intercept, this point right here is equidistant to both P and Q. Any point on the line has the same distance to P and Q. And that is the solution to this problem. And that ends this video.